A very good evening to all the guests who are present here in this session. First of all, let me find out if my voice is reaching out to you all. Am I clearly audible? You can put a yes in chat if I'm audible to you and you are able to see me. So yeah, I'm clearly audible. So the responses have come and you can see me also. Well, let's start the session formally. Good evening to all the guests who are present here in this session. First of all, let me find out if my voice is reaching. Well, to begin with this session, first of all, I would like to welcome all of you on behalf of EduSoft to this small, quick session about how we can engage kids, how we can bring children towards, how we can lead children towards coding and nowadays what we call about robotics and all, everything. So before starting with that, first of all, I would like to have your opinion about this. What are your expectations about this session? If you can please share what came into your mind when you were planning to attend this session and you were joining this session. So what was on your mind? What are your expectations here? You can put it in the chat, or you can raise your hand. I'll unmute you, and you can speak up also. So I have just allowed, you can unmute yourself and you can share your opinion as to what do you expect from this session today. When you read the title, Bringing the Children Towards Coding, what came to your mind? If there is difficulty in connecting on audio, you can put it in chat also. So we have a few teachers around here. Well, kicking start forward, I did not get any response as such here. So let me figure what could be the expectations of yours. As the title says that you all are teaching computers in your school, and the biggest challenge in getting the children excited about coding and this robotics. So you might be teaching computers and codings in different classes, and you might be at different levels of teaching nowadays. So before starting the session, I just wanted to know if you can give me some idea what are your expectations, what do you expect out of this session. Then it becomes easier for me to orient the content, to orient the discussion accordingly. So I would really appreciate if you can share your mind with me. What brings you here in the workshop, in this particular webinar? You can frankly type in the chat also, or you can unmute and speak up also. And language is no bar here. We can go for Hindi, English, whatsoever. The point is that we share the thoughts and we speak up. Well, Prabhat ji has shared that to get the knowledge, can you Prabhat ji a little elaborate on that? Got the knowledge, like should I interpret it as you're looking for what sort of knowledge is required to conduct the coding classes and conduct the coding course in the school? Is that so? If you could little elaborate on what you have mentioned here. You can unmute yourself and share your thoughts with us. Prabhatji. Any other teacher? Pragyanji is there, Sashmita is there. We can share our thoughts. Deepti ji is there. Well, when we actually talk about teaching coding in schools, there are two aspects. One aspect is that we have the book, we have the curriculum. The book is there, which has got the chapters, and we teach according to the timetable. We teach according to the curriculum which has been set in the school. That is one aspect. The other aspect is that other than the book, many schools have their own IT clubs. They have their own IT activity, coding clubs nowadays. So through that, the students are given a separate formal training about coding. So these are the two aspects. One, coding is being taught in the school as part of the books which are there. And then there is a separate need of coding which children can pursue through a course introduced by the school separately in their IT club or in their coding club. So as far as the books are concerned, we have, according to the age, we have the book content which is being taught to the students. For example, if you talk about class 3, class 4, and class 2 students, they are very small for coding. And in earlier webinars also, we have discussed this, that they are too small to introduce full-fledged coding to them. It's not possible. So what we do is, for the smaller kids, we engage them into certain activities which help them into developing their logical thinking, stepwise thinking. They can think in terms of what computer does, what is input, what is processing, and what is output. So on those lines, we create certain interesting activities through which we engage the children, and we just make them aware that there is something called coding for which they need certain skills, certain very basic skills, which can be developed at their age. But of course, they cannot go for a complete coding until and unless they grow up and they move on to, they reach up to a right age. Now, there is then this middle group. The middle group is from 5 to 8, 5 to 7, we can say. 5, 6, 7 is the middle group, which shows the potential of understanding coding, learning, programming. Now, this group is curious. This group is difficult to handle because they are very curious to learn. They have 100 questions to ask, but they still have not reached that age that everything should be taught to them, everything should be explained to them in terms of coding. And then there is the third group, which is very easy to handle in terms of giving them knowledge. That is from class 8 onwards. From class 8 onwards, child is grown up enough to understand what is coding, what is programming, what are the concepts related to coding and programming. And they can be easily led towards learning coding fundamentals, even using a serious programming language. So this way, we have to cater to these three groups: smaller kids, the middle-aged ones, class 4, 5, 6, and then we have 4, 5, 6, 7, then we have class 8 onwards. Now here what we are talking about, whom we are talking about, the first thing is, the first big question is that what kind of challenge do you face when you are teaching coding in school, in the classroom? What kind of challenge do you face while teaching and while imparting that course? Is there any challenge you face particularly? You can share it with us. You can share it in chat, or you can speak up. I would love to hear your voice talking about the challenge which you face while teaching coding in your school. Or you might be planning to launch coding curriculum and there you face some challenge. That challenge could be of the knowledge, that challenge could be of the skill, that challenge could be related to the availability of the resources using which you can teach the children. Challenge could be related to infrastructure. It could be related to software, hardware, whatever it is. If you can let me know, what challenge do you face while teaching coding in your class or in your school?
Yes, sir. So basically, the first challenge that we face is that Python starts from grade 6 in our school. So
Okay.
the thing is that the students are not very well acquainted with the coding basics, and we have to
Right.
start a language. And in
Hmm.
that language, we have to start the topics. We have to cover the topics within a limited period of time.
Yeah.
So when the child is not acquainted with the concepts, basic concepts, we have to let them know the basic concepts, and that takes time. So I think for computers, the time duration that is given to us, the number of classes that are given to us, that is, I think, not justified now, because the syllabus is around, like, you can say, more or less the same with the main subjects.
Right.
So
Right,
if
ma'am.
the syllabus is same, then the classes and the number of the classes, the number of teachers, and the number of lectures, they should also be same.
Right. So here, actually, the challenge is related to the fundamental challenge is to teach the child something for which he is not prepared as such. If I'm going to teach
Yes,
Python,
yes.
and if I'm going to teach programming, they are not well aware, and that's not their fault also. The way they have been taught, they have come through, some students come from different schools. So there is no consistent curriculum across the schools. That's a big challenge. That's a policy issue. But yes, you are right, ma'am. The time is another big factor, because what we see, it's on the timetable. 2 classes in a week or 3 classes in a week. 3 is a luxury for a computer teacher if a third class is there on the timetable. So time is there, and that timetable has been set according to the chapters in the book. So here the coding, which is a very core skill, is being treated like just another subject in a very traditional way. And it is just a matter of completing the course of the child, completing the book. So time is the main problem. Another teacher, Prabhat sir, has also shared here that time is the main problem. Now, as far as time is concerned, if you look at the timetable and if you look at the book, you are bound to cover all those concepts in that particular time. And for that particular time, you can only make the students mug up the exercise, question answers, a few programs. Out of those 3 programs, you make them practice some programs, and you ask the same program with little modification in examination, practical exam. Mugging up of the question and answer, they write the answer sheet, and they get the marks and they pass on. This is what is happening actually. But this is not what new education policy needs. New education policy actually actually asking the schools to change the way they are teaching, they have been teaching so far. So it's a matter which has to be put forth in front of the management of the schools, that look, this kind of change is required. The computer teachers and other teachers have to put forth this idea that the way we are teaching traditionally through a timetable, of course, timetable has to be there, but a lot of innovative change has to be done in the timetable. For example, a teacher must be given with a class at least 1 or 2 hours to spend regarding coding. Because if you are teaching coding, at least 2 or 3 periods should be combined to talk to the children, because in 40 minutes, you cannot put across your idea, whatever concept you are explaining. So that's really a big challenge. But there is another way out. If we can, but then that will add to additional, responsibility and additional workload on the teacher. If you are doing this activity, weekly activity, through a computer club or IT club, in computer IT club, you can introduce a 12 hours or 10 hours a small course of computer where students can come once a week for 2 hours or 1 hour activity. It can be taken as a weekly activity also, and where you can teach those children about the very basic concepts of logic development and coding instead of a particular language or instead of a particular software. So this is one way where you can manage some time, maybe 4 hours in a month, to teach the children about basic coding fundamentals. So that is one suggestion I would give. because that is only possible. You are also working in the school like other teachers. You are the part of the team and you're not the decision maker. So these are the decisions which have to be taken by the management, the principal, and the middle management, and they need to understand that this is very much required. Well, when we talk, if you're sticking to the book, you can do nothing. In book, you are just completing the course. So here, if a class 6 student is sitting in the class and he is going to learn Python, and he has no idea of any programming fundamentals and logical approach, that entire Python would be a nightmare for that student. And for the teacher, it would be a big challenge to explain it. And then everybody would be asking the teacher why the students are not understanding. You are a good teacher, but the problem is not there. Problem is somewhere else. And that problem has to be tackled by additional activity class once a week or once in a fortnight. Either you can do it in a fortnight for 2-3 hours, or you do it weekly for 1 hour, 1.5 hours in a week. So that has to be put in, that effort has to be put in to bring the children towards understanding the fundamentals. Now, this is one thing. That is my suggestion towards solving the time problem. Now, in that activity period, in that additional interaction time with the students, what exactly are you going to do is the question. You are not going to touch the book. You are not going to complete or cover the course. It's not for that. Here you are going to tell them something which is not there in the book. For example, we dedicate only one chapter towards flowchart and algorithms in the curriculum, because we cannot teach algorithm and flowchart for the whole month. But in activity period, you can take more time to teach them algorithm and flowchart, because that makes the very basic fundamental of learning programming. Unless they understand the basic approach towards programming, they cannot do that. So algorithms and flowcharts are the best tool which you can start with. And slightly, we have to change the way we teach in the classroom. That will be completely changed in activity period. In activity time, what will happen is you will not follow the basic traditional norms of teaching. That happens in classroom. Here you have to break certain rules. Here, what you do is you apply the reverse approach. For example, if you are telling them about a program, for example, there is a program which takes 2 numbers, multiplies them and displays the answer. It's that simple. What you do is you show them the complete running program. If possible, let them run that program. If that program is available on the machine already, that's very good. And you can make the students run that program. Whenever you're going to teach something, my approach suggests that you show them a running sample. You show them something which is completely working, and then you work out in the reverse direction. When you show them the program, let them observe the program, and then you start a discussion with them. That what did you observe in the program? What is happening? What did the program do in the beginning? Then you come to those kind of questions which are actually starting their high order thinking skills. For example, you ask them that if I have not done this thing in line number 2, what would have happened? Or if I had input this kind of value instead of that, what should have happened? So if you are teaching a program where if and else is involved, and you are entering a value, say 0 has to be entered, you ask them what would have happened if I had entered 5 there, and let them speak up, discuss. So this kind of interaction will give the opportunity to the students to think. So there you are not teaching, there you are bringing them forward to speak up. That is giving them the opportunity to self-learn under your guidance. You are there in the classroom. You are the facilitator, not the teacher in the activity session. So as a facilitator, you talk to them, and it has to be very well planned. Your discussion should be in such a flow. Whatever students speak, you should be in control. Whatever they say, you discuss on that, explain the concept, and then you steer the course of the activity the way you have planned. So this way, you show them something which is already working. For example, if you are going to teach them Scratch, or if you are going to teach them Python, running program. So this is my idea. Number two is, the very first thing which they have to be taught is called anatomy of a programming language. Anatomy of a programming language means, without taking the name of any language, without referring to a particular language, taking an example of Python, JavaScript, Scratch, or Java, or C++, without taking that examples, those references for any particular language, you talk about pseudocode. You talk in pseudocode, semi-English. So you speak with them that how does the computer think? So they should have idea that a program which, when it gets loaded into the memory of the computer, what happens line by line. So what happens when the first line is picked up by the computer? What happens when the second line is picked up by the computer? And then you relate it with the input process output cycle. So you teach them very first that the basic skeleton of a computer program is always some input is being taken, something is happening in between, and some output has to be given finally. There could be intermediate inputs and outputs, but there is always a final output. So this way, students have to be taught about, first of all, input, processing, output, this kind of thing with the help of a sample program. You demarcate them that these particular lines are constituting the input part. These lines are constituting the processing part, and these lines are constituting the output part. This is one way. The other way is, we give them the opportunity to come to the solution themselves. When you give them a problem, I recall my training days when I was learning computers, we had a teacher, I still recall his name, Kirti sir. What he used to do is, he never used to touch the keyboard. He never used to touch the pen and pencil. He always used to stand and discuss with us. There was a problem written on the board that this is the scenario and this is what has to be done. And then he used to start the discussion, and his discussion was so smooth. He used to ask pre-planned questions to us. Now we know that those were pre-planned. That time we did not. So he used to interact in such a natural way. Like, for example, he said, okay, aap log ke scenario samajh mein aa gaya. Have you understood what is supposed to be done? So he used to ensure that everybody has understood what is supposed to be done in the problem. Number one. So problem understanding, the stress on problem understanding is the most. So whenever I tell you 80% problem is, students do not understand the question at all in the computer programming especially. So if you ask them what is HTML, they know. If you ask them what is the difference between container element and empty element, they know, because they have mugged that up. The answer is there in the book in black and white. But the moment you ask them a logical question, they are not able to answer. Why? Because in programming, they need to understand the situation. They need to understand the problem first. So that has to be ensured, number one. Number two, now bit by bit, that problem has to be intercepted and the solution has to be revealed. So what our trainer used to do with us is, he used to ask us, okay, if you have understood the problem, tell me at one glance, at first thought, how many variables do you need? How many variables do you need at first glance on the problem? So we used to say, okay, sir, for this problem, we need 3 inputs. So we need 3 variables, one for this. So 4 variables, 5 variables, whatever. So after reading the problem again, the students will come to the answer that we need 2 variables or we need 3 variables. Okay. Note them down on the board. So here you are not explaining them what that particular program is doing. You are explaining them the anatomy of the programming language. The very basic thing is, if a program is taking the input from the user, where that input has to be stored, of course, in a variable. So if there are n number of inputs, there would be n number of variables. In a general situation, I'm not talking about a complex situation of loops. So you ask them how many variables are required. So this way, they will be solving the problem along with you. अभी क्लास में क्या हो रहा है, what is happening in the classroom? Teacher is sitting on a throne. Teacher is an authority. Students are receiving the knowledge. Teacher is imparting the knowledge, and students are obeying or following the instructions of the teacher. But in activity period, there is no teacher. Teacher is dissolved with the students. Teacher is sitting with the students like their group leader. And it's a democratic team now where everybody is equal. No student, no teacher. It's a group where one leader is talking to them. There is no sense of authority as such. And teacher is involving the students like a team to solve that problem. Responsibility is lying on the students also. So they love it. They start answering 3 variables. Somebody will say 5 variables. They start discussing with each other. They will ignore the teacher and they start fighting with each other. 5 वेरिएबल कैसे हुए, मेरे हिसाब से तो 3 हुए, तूने ज्यादा ले लिए, एक वेरिएबल देख तुझे आगे जरूरत पड़ेगी. Let them speak, let them interact. So we come down to a number of variables. Okay, इतने variables चाहिए. Next, you move further into the program. Now you pick up a tool that is what I call a trace table. No small or big program in the activity period should be taught without a trace table. A student should be ready with their notebook and pen, and they should draw the trace table on the page. What is a trace table? It is just a simple table, and each column is holding a variable. So if the program is taking 3 variables, A, B, C, the trace table will have 3 columns, A, B, C. So as the program will be executed line by line, not on the screen, not on the computer, but theoretically on the board, walkthrough that we call. As you walk through the program line by line, the student should fill the trace table. At the given moment, what is the value in a particular variable? So program runs 10 lines. There should be some value in the variables that has to be filled by the students. Program moves on to line number 12. Whatever change happens in the values of the variables, that has to be noted down again. So students will fill up stepwise the trace table where value of each variable has to be filled. And when they do this activity, they will be able to follow the program. You are actually teaching them how to understand a program. And if they practice this for a given sufficient time, no program in the world, no computer program is there which they cannot understand. Because when they go stepwise and they keep filling the trace table, trace table is actually tracking the variable's value. They will always come up with the correct output. They will always come up with the correct answer because the current value of variable is updated on the paper, not in the mind. But generally what happens, we are showing them a program and we are asking them what this program is doing. Then the students are trying the program on the computer. Programs runs in a millisecond and gives the output. And they are just satisfied, okay, the program is working. I have entered 3 numbers and they are multiplied together. Program is giving the correct answer. But they have never been put into the situation to stepwise understand what the program is doing. That was happening in the classroom, but that was happening with a particular program only. Here you have to do this exercise with every program in the activity so that it becomes their habit. When they look at the 10th program in their life, by the habit, they start tracing it. And the moment they start tracing it, they don't need you for explanation. They can understand the program which is written logically, either in a pseudocode or in Python or in Java or whichever language they know. Of course, they should know that language. So this is one approach where you use the trace table. That helps a lot to the average and below average students who actually do not understand, who are very slow to understand, to grasp the things. For them, trace table is very effective. I suggest you that you make use of trace table. You ask them to make a separate notebook and put a heading on it, trace table. For every program, they should fill that. And you must have a look at it, how they are filling it correctly or not. So this is one thing. Then you ask them, if we are going to use these many variables, what kind of value will be stored in each variable? So data type has to be ensured. Number 1, how many variables do we need? Number 2, what will be the type of each value which is going to be stored in a particular variable? So they have to be very clear about the data type. So if you are saying that accept the date of birth and date of joining of an employee, that's a date type of value. If you're accepting age, it's numeric. If you are accepting price, it's numeric. If you're accepting the name of the user or the password or the username, that is text. So stick to the basic data types. Don't go into the nitty-gritties of float and double and Boolean and all that. That is specific to a language. You are teaching them programming approach. So that is just a number with decimal places and text. That's it. In rare cases, it's dates. So this way, your focus is on actually the teaching the flow of the programming. Now they have understood that, okay, these many variables are required. So they are okay with what input is required. Now you ask them what input is required, what all input. They will be able to easily answer this question because they have already decided what variables are needed. You cannot decide the number of variables unless you know what input you are going to take. So they will immediately tell you, ma'am, in this program, sir, in this program, we need to accept the age of the user. We need to accept the date of birth of the user or the price of the item or the PNR number of the passenger, whatever. So you are putting them on track. And here we are not trying to write a program. We are trying to analyze the situation. We are trying to analyze the problem, understand the problem, and then we are trying to construct the solution by analyzing each and every step. So once they tell you that these values we require, so you tell them, okay, suppose somehow we have taken all these values input into our program. Now, how will you process these values? The problem says that this has to be checked. So how will you check that? So with every small question, with every small discussion, the solution should be revealed slowly. So you are telling them the answer, but not directly. One way is that you are writing the program on the board and explaining it, and it is done. That is good in classroom. You don't have time. But in activity, do not write on the board. You discuss with them. Let the answer come from their mouth. You give them enough hints. You give them discussion. But let them speak up the answer. And when they are very close to the answer, then only you write on the board, okay, this is done. So we are going to compare these two values. So how do we compare these two values? For what we will compare these two values? One value is greater than the other. So if we are going to compare the two values for greater than, what kind of operator do we need? It's an operator called greater than. By symbol, it is one angle bracket. So this way, you slowly, in one activity, you might be discussing a 5-line program, but you discuss that 5-line program stepwise, asking questions with them. So this is one effective approach towards brushing up their fundamentals. And when in a weekly activity, if you are doing this exercise with them, this kind of activity with them, when they come into the classroom, the same kind of approach they will apply in the classroom also, and it will be easier for you to quickly explain the things to them, because in classroom you are showing them the actual program. In classroom, we are showing them a program in Python, which is using an if-else or a for loop. Fine. But they have already done the trace table. They are already in the habit of thinking, how many variables do I need? How many types of values do I need? What would be the type? What would be my approach next? What would be my step number 4, step number 5? So they will start understanding that with that thought process now. So your approach has to be in the activity period is to change their way of thinking to understand the programming. So this is what is required. When I used to teach when I was a trainer and I used to train that programming to the students, for the first month, I had that liberty because I was not in a school, I was in a professional institute, and I could decide certain things on my own. So my classroom was my world, my rules. So I did not used to touch the book. I used to tell them, keep the book aside, it has nothing. It will be useful after 1 month. So for 1 month, I used to talk to them. I used to apply this approach, trace table, talking to them, giving them a situation. There was no talk of Java language. There was no talk of C++ or Python. I wanted them to forget about the language for which they have registered for the course. for which they had come. I told them, keep your mind blank. Do not think about any programming language. Only think about programming. No language. The only programming language we have right now is English. So I used to write theoretical programs, accept the input, declare a variable, compare the value. If this happens, do this, and a lot of talk in the classroom, a lot of writing on the paper. And then I used to show them a flow chart. I used to tell them that whatever we have discussed, whatever we have thought, your rough work on the paper can be shown, can be expressed in a graphical form by the help of a flow chart. Now, another mistake what we do in teaching the flow chart in the school is we start teaching the flow chart immediately correctly. We start whenever you recall your classroom when you have to teach the flow chart. What do? We show them a flow chart. Good. We first of all show them a complete flow chart and we tell them how the flow is happening. Then we tell them the definition of the flow chart, the advantages of the flow chart, all those things which are important to gain marks. And then we tell them what are the basic symbols and what is their meaning: start, terminator, and starter, and decision box, and what do we call it? Input box, display box, various symbols we explain them. Now, you will be surprised if I tell you that this is an incorrect approach of teaching flowchart. It is just like I'm saying that if somebody has come to you to learn how to drive a car and I'm telling you not to use the car. Well, it's not the right time to use that car. When you are teaching flowchart, do not worry about symbols. Do not worry about triangles or boxes or parallelograms or rectangles. Okay. Whatever you have been discussing with the children about the approach of the program, whatever they have written in rough English on the paper, you tell them, class, you convert this into a chart. You convert this into, do not use the term flow chart. You tell them, can anybody convert this into a visual form, in the form of a chart where you can show me the flow with the arrows? So they will say, take input from the user, arrow, calculate, arrow, do some comparison, arrow, finally the output. So you are not teaching them flow chart. First of all, you are taking them towards an intermediate level. That intermediate level is whatever is written on the theory, whatever pseudocode is written on the paper, it has come into a rough graphical form. They do not know about flowchart as yet. Now, when this rough graphical form comes, then you tell them, okay, class, if you see, there are various kind of operations happening in this flowchart. Arrows are there and boxes are there. Why not we give them a distinct identity so that visually I should be able to know that this particular box is taking input. This particular box means it is doing some calculation. This particular box means it is comparing and making some decision. And two branches might come out of it. Yes, no, true, false. So what you are doing is you are slowly transitioning them to the actual flowchart. Still, you are not talking about actual flowchart, but you are just discussing. And then you, instead of opening the book, you convert their rough arrow wala program into actual flowchart. कि okay, इस बॉक्स को हम ऐसा बना देंगे, ये डिसीजन ले रहा है ना, इसको हम एक डायमंड में बंद कर देते हैं. Now this diamond will, there are two conditions, so let us take out two possibilities, two arrows, and slowly, without opening the book, without showing them any actual flowchart, you converted their rough flowchart into actual flowchart. And while doing this exercise, they already now know that this diamond is decision, this square is calculation, this parallelogram is input, this D-shaped is output. They now know because they have done that exercise with you. You have involved them. It is as if they have invented those boxes themselves. Nobody else knows about it. That kind of feeling has to be there. So this way, from pseudocode to a rough arrow-based flowchart, and from that arrow-based rough flow chart to the actual flow chart. Now you open the book, show them a complete, neat, very well printed, well organized flow chart on the paper, which is there in the book. You show them on the projector, and then you explain it, they will quickly get it. So what we are showing them in the first 5 minutes in the classroom will come in the middle of the period. In the middle of the period, maybe after 15-20 minutes. Before that, you are just doing the exercise with them. So this way, we can, I'm just sharing you certain approaches which you can apply in the activity period. In classroom, you do not have that much time. But in activity period, you can put them into a situation. Always the best way of explaining logic development is to put the children into a situation. That situation could be a programming situation, and that situation could be a life situation also. You can give them a scenario where let them make the decision what is right and what is wrong. And then you can bring them towards the programming. So suppose you take and you start taking the situations from around the daily life. For example, if they are making decisions and they have to develop the logic, you can bring in the situation of a lift in a building. Most of the people are living in multi-story building where lifts are there and everybody is familiar with them. So you make a situation that there is only one lift and somebody is there on the ground floor. He has to go on to the 10th floor. And what will be the approach? That is fair and simple. Then you bring in another lift. Now there are 2 lifts. The lifts which is the nearest and which is free will come first to the person. So this way, the scenario of the lifts in the building, the scenario of an ATM withdrawal card, ATM withdrawal, the scenario of ordering the pizza in the Pizza Hut. You go into the restaurant, and what is the flow of placing the order, making payment, and getting and collecting your order. So that approach can be used. So you pick up the scenarios from around the daily life. Booking a cab, you can take the example of Ola and Uber flow, task flow, how the cab is booked and it comes to pick the passenger. You can take it further, dropping the passenger and doing the final payment. Or you throw in some exceptions that once the journey has started, now passenger wants to change the destination. The passenger wants to cancel. The passenger wants to go back or wants to cancel and book another cab. So various scenarios you can throw in to let them think how the flow of the program will change. And nowhere you are using any programming language while discussing all this. So this is how you, in activity period, you build up their logical thinking through various tools. You can even make use of simple software, like for making flow chart, you can give them a diagram making software. Many free diagram making software are available, or they can go online and create flow charts online on the computer, or they can do it on paper. First of all, they should do it on paper. That's the best practice. So making use of trace table, making use of flow charts and algorithms, if they are able to write the algorithms correctly, let me tell you, 80% of the thing is done. If your student is able to write the algorithm correctly, that means he has started thinking logically. The only work has to be done is on the syntax now. And when we talk about syntax, then a particular programming language comes in. Abhi, what is happening is, Abhi, I am going to teach them Python in the classroom. So the children have 2 challenges. First challenge is to understand the logic, to develop their logical skill. And the second challenge is to understand the Python language, to understand the syntax and grammar and usage of the Python language. So their mind is split in the classroom. Mind is confused. Should I understand Python, or should I understand the logic behind the program shown on the screen? So in activity period, you are developing their mind for logical thinking. Slowly, what will happen with this practice in a year, 6 months, 1 year, in next session, when the same child goes for further studies, his mind will not be split down. Once their logical thinking is developed, then they will focus only on the syntax. So in your activity period, you do a lot of paperwork, you do a lot of discussion, and with your questions, you lead them towards the solution. Let them write the solution on the paper, not you. You only ask another question. Whenever you see that they are not still on the track of the correct solution, you give them a question or a hint, but never tell them the solution beforehand. No matter in that activity period that one day solution is not reached, does not matter. But you walk them through with your questions and with your hints only. That's the best approach, because in activity period, you don't have a set curriculum. You have time to do that. In classroom, you just stick to the curriculum. Traditionally, whatever is happening, don't worry about that. So this is my suggested approach towards developing their logical approach, logical thinking. So at this moment, what do you say? Whatever input I have given you so far, if you have any opinion, if you have any thought on that, you can share with me right now. Or any idea comes to your mind, you can share that. Everybody will benefit with that. Anything that comes to your mind, you can speak up. Then we move on to the next section. So I suppose so far, whatever I have discussed, most of the people might be knowing about it. And of course, nothing new I have shared with you. And you might be using this approach already, maybe in the classroom itself, or maybe some other tools also. I have just discussed about 2-3 tools. Now, when we talk about coding as a separate curriculum, dedicated curriculum, not of the school curriculum, there are many aspects to it. One is application development. Application development means learning a language and then start writing solutions in that language. That is one way. The other aspect is there are various facets of the programming. The other aspect is your web designing. Now, when web designing comes, there are two things: markup language and the scripting language. So these two come in together in web designing. Then there is an approach where there is front end in the form of HTML or in the form of a GUI created in the programming language. For example, in Python, if you are making a GUI, you might use this KTinker library, or in Java, you might be using the Swing library, or you're using simple HTML, or in Visual Basic, you are creating a form, VB.NET or Visual Basic, or in Visual C++. Well, this is one aspect, the front end. The second aspect is the back end. Back end, some students are very good at back end in terms of database, designing the database, organizing the data, and ensuring how the data is connected with your program to fetch the details from the database and to interact with the database. And then the middle tier, as we know, the middle tier is the basic business logic, the actual program which will connect the front end and the back end together. So that contains the actual programming which will at one end interact with the user and at the other end interact with the database. So that is one complete solution which we follow in higher classes. But still, the school curriculum does not talk much in detail about it. So this is one aspect. Then application is there, coding is there. And then another aspect is developing games or animated storytelling. Creating games is another good way to develop the logical skills. For that, you can use this Scratch or MIT App Inventor, using which block coding, or you can use Google Blockly. Using these block coding tools, you can ask the students to create a simple game. If I click on a sprite and that sprite moves into a circle, or if a sprite is moving randomly on the screen, I need to click on it and win the game. Simple, very simple game, not much creativity. Do not go into a complicated creativity. The idea is to develop the logic. So developing a simple game is the best way to develop the logic and understand what is happening in the program. And a lot of challenges come into the game. When we work around those challenges, we unknowingly training our neurons how to think logically. So developing game is another good approach, but that is not for everybody. Developing games is a matter of interest and of course matter of time. So for a teacher as busy as you, teaching through games is a very complicated and time-taking thing, because for that you need to create at least 3-4 games yourself. Where is the time? Or there should be somebody who should give you the ready-made programs, simple programs, which of course EduSoft does. EduSoft has a collection of programs which we can share with you. And on our website, it is all there in public domain. You can go there and you can see the code also. You can download the code also. So if somebody gives you the running program, then you can take it to the classroom and you explain that program and tell them to create another game like this. So this way, that is a different kind of skill, and every teacher does not have time to develop that skill. So that is just one approach of choice, which I'm suggesting. Then there is another aspect is mobile application development nowadays. Instead of creating web services, we develop mobile apps, and in future, the curriculum will also include creating apps extensively. Right now in class 1 to 8, we have just 1 or 2 chapters introduced about mobile app development through some tool like MIT App Inventor. There are other tools also, Google Studio is there. But there is not much because children are very small. The functioning of the app, user interface, the functioning of the code of the app, and then converting the app into a .apk file and installing on the mobile phone, testing it, running it is a complicated task. So that's not for small kids. So that's why it's nothing much is talked about in the curriculum. But in your activity period, you can bring them to a full-fledged MIT App Inventor session also, where they can create very interesting apps where they draw with the finger, because on mobile phone you have the touch screen. So you can create a drawing application where they can move the finger and the black line is drawn, or they can have a small game where 2 random balls are appearing and they need to click on the ball to win the game. Or they can create a data entry screen where they input the data, the contact list of the friends. The contact list of the friends has friend name and the contact number, these 2 fields only. So they input those values and it is stored in a database. MIT App Inventor has a small database utility also. And then they can perform query. If they enter the number, they get the friend's name. If they enter the friend's name, they get the number. So those kind of simple applications can be introduced in your activity period to develop the logic. Again, I am repeating, the purpose is not to develop a program or a service or a solution. The purpose is to develop the logical thinking skills. So these tools, which I am suggesting, they can be planned very well in the activity period, and there you can engage the students to do that. But to do the activity successfully, some preparation you have to do beforehand. You cannot do any activity period without any preparation. So this way, another example I would take where very small children have to be taught about memory, keyboard, variable, and all that. You can convert this scenario into a small play, small, you can say skit, where one child is playing the role of a keyboard, another child is playing the role of the RAM, another child is playing the role of a monitor, one child is playing the role of a variable. So a program, if the program has 3 variables, then 3 students are playing the role of a particular variable, and the flow of the program becomes the script of the play. And a user tells something to the student in the ear, who is the keyboard. He goes and tells to the RAM, and then RAM tells to the variable goes to the processor, the student who is the processor, and he performs the calculation. And this way you can let the students play a small skit around the program, and you tell them this is how this is what happens when the program gets loaded in the memory of a computer. So what happens, you can ask the students, when you double click on the icon of the program, or when you run the program, where does it run? It runs in the RAM. So what happens to the program when it gets loaded into the RAM? So you try to make it visually visible on the board, either with the diagram, or you can visualize it with the help of a small play that one student is playing the role of RAM. So the moment they go into that play mode and the moment they see the visual graphical of the teacher, they will understand that every program gets loaded in the memory. There's a memory address where it gets loaded. The moment that line comes where it is saying declare variable A, B, C in the RAM, where buckets A, B, C are created, now it is taking the input. When it is taking the input, the control goes to the monitor, the cursor is blinking, and the program is waiting on the monitor for the user for input. User will give the input through the keyboard. User types the value from the keyboard. It goes into that variable, which is mentioned there. So what you are doing, you're helping the students to visualize the program, which is written on the paper. So they should be able to create the picture of the program in their mind. Everything in picture. And the moment they learn how to create the picture of the program in the mind, they can develop the logic easily. Because graphical makes the things easier. So you might have seen so many YouTube videos where the concepts are explained with the help of a moving diagram, with the help of an animation. So why not use that technique in your teaching? You think of a program as if it is happening in the memory, real life. So the program goes into the memory, visualize it. The program is creating 3 objects, visualize it. The program is opening a file, visualize it. The file is opened. The file pointer is on the first letter of the file. So this way, once you start visualizing, once your students learn how to create a picture in mind of the program, the things will be easier for you as well as them. So these are certain tips which I am sharing with you, which you can use in the activity period. One day, if I find time, I will demonstrate this. I might be able to demonstrate you all this, actually what I'm telling you. So let's see, maybe one day I show you how to do all this, how to conduct these activities with the students. Or maybe if I come down to your school someday, I'll show you how to do that. But being a teacher, you already know many things, how to do that. You are innovative, you have very high order thinking, and you can do well than me. You can do better than me. So these are certain tips which you can introduce, but of course, this will not happen in classroom. This will happen in a separate activity period. So first thing you need to do is when you go back to school, you somehow convince the principal that you need an activity period at least twice a month or once a week to interact with the children. And in that activity period, maybe those children can come who are interested. Coding is something which is not interesting for everyone. There might be 30 students in the classroom, but only 10 would be interested in actual coding. Rest of them are just finishing the course, getting the marks, passing on to the next class because they don't like it. And it's not their fault, it's a matter of choice. Like many students do not like Hindi, many students do not like science, computer is also there. So students are very good when they are making drawing on the computer, when they are playing game on the computer. The moment Python comes, the moment something challenging comes, they lose their interest. They are those students who are not interested in programming actually. But the students, those 10, 12 students who actually want to learn programming, for them you do the activity. Because they will only come and they will only benefit from it. So you can invite the whole class to the activity, but you expect only 50% of them actually taking you seriously there. But that's a matter of choice, and you cannot do about anything. Maybe you can only encourage and you can inspire other students to join in. But that's only an effort you can do. So this is my short discussion with you regarding the approaches. Then we come to another aspect of it, the design approach of a solution. Let me take an example. You being teachers, you all have read books, various fiction books. Some are interested in drama, some are interested in romance, suspense, thriller. You might have read some fiction books. or any magazine or a story. Now, if you are asked that, okay, this is the book which has to be converted into a movie. Now, you might have seen certain movies which are based on certain books. And if you have read the book, you will feel that movie is little different from the book. The treatment in the book of the story was different in the movie. Why is that so? Because when you are writing a story, when you are writing a program, for that sense, in programming, when you are writing the story, it is a flow of the thought on the paper. But when you are making a movie on that story, you are actually not creating a story, you are constructing the story. A movie is always constructed like a house. And a story is always conceived, a story is always designed. So there is a difference. So when the story in the novel, in the book, has to be converted into a movie, first of all, it will be converted into a script. The characters are speaking their dialogues. And it will be having description of the scene frame by frame. That is called screenplay. So the story has to be converted into an screenplay. And that screenplay will make the foundation for the movie. And many things will change, which are there in the book, which are not there in the book also, because a movie is a visual thing. And that book is a text. There would be many graphical things which will be introduced in the movie which are not there in the book. And there would be many things which will be taken away from the actual story when they come to the movies. So similarly, what happens in designing a solution? Designing a solution is a construction process. And you cannot construct anything unless you follow a particular approach. For example, if you are going to construct a stack of bricks, you cannot put the topmost brick in the air, defying the gravity, and then you putting another somewhere randomly. You always have to put the first brick down, the second brick on top of it, the third on top of it, and so on. You are creating a stack. There is no way, we are not on moon where we put any brick anywhere and we try to put them together. There is no other approach as such. So similarly, there has to be a particular approach in designing a solution. For example, if some teachers are complaining in the school that they could not hear the bell and they never came to know that the period was over and they kept teaching. The other teacher was waiting or they got late to reach the other class. That's the problem area. Now, a committee of experts was set up to find the solution to this problem. So they said one solution is we install a speaker in every classroom. Very good. Then somebody suggested about software. So they said, why not create a software application which knows about the timetable, and as that time approaches, that software sends a signal to the bell, and that speaker bell in the classroom rings. So that kind of software has to be developed, which according to the daily timetable rings the bell and reminds the teachers also in which class they have to go now. So that's the idea which has brought up to develop a software. Now, what would be the approach of designing this kind of software? So these kind of things you can discuss with the students in the activity period. Do not go to the actual solution. You are not going to develop the actual software, but bringing up these scenarios, open up their thinking. They start discussing, okay, ma'am, what do you need first? First, we need to have the timetable in place. And we need, what kind of language should we use? We know Python, ma'am, so we will develop it in Python. Okay, Python. Or maybe some little bit of HTML and JavaScript, if not Python. So how do we go about it? So what should be the approach? Now you have come into graphical. You have picked up your pen and you are making arrows and boxes on the board, on the whiteboard. So they all have come into a discussion mode. They are all discussing something, some approach. So this is the rough approach towards the solution. This is not a standard structured approach. What you are doing is you are stimulating their power of thinking. You're stimulating their power of discussion. And you're stimulating their capability of convincing and argument. and selecting the best approach out of it. So with many heads, many kind of things will come up. Somebody will oppose, somebody will agree, somebody will disagree. And they will slowly, with you being the facilitator, they will come to a common solution. They'll come to a common agreement. Now you slowly take this approach towards something called object-oriented analysis and design, or simply saying system analysis and design. The short form is SAD, S-A-D. We used to call it a very boring topic, but it's the most interesting topic. Finding the solution to a problem. That approach is system analysis and design. So you are actually preparing them for system analysis and design. Why? Because when you will give them the actual problem, that there are 100 employees of 5 different departments, you have to accept the salary of each of the 100 employees, and then you'll have to display a report department-wise, how much salary has been given by the management. Now you have given them a concrete problem which can be done in Python, which can be done in MS Excel by the help of formulae. If not in programming language, it can be done in MS Excel. It can be done with the help of a database by the help of SQL. So approaches could be different, but every approach requires logic. So this is a scenario, department-wise salary expense out of 100 employees. A lot of things are there to think about and to discuss. So you give this thing. Now in the activity period, you have discussed with them system analysis and design. Not by this name, just the approach to design a solution. Now, this concrete problem actually needs system analysis and design. So let them think what all is required, what is the input, how many variables are required, what kind of value we are dealing with. Are we going to use any decision making? Are we going to do many things repeatedly? What will be the beginning of the program? What are the preparations required? What will be the format of the report? What will be the layout of the report? So all those discussions will happen on this problem, and you will see your students doing system analysis and design without knowing about the term. So this way, later in your activity period, you can introduce to them object-oriented analysis and design. So you would give them a scenario of a furniture shop. In a furniture shop, there are different kind of furniture. So there is a furniture which is used to sit on, and there is furniture which is used to work on. For example, chair, sofa, stool. These 3 are the furnitures which are used to sit on. And table, desk. These are the furniture which are used to work on. Then there is cupboard, drawer. These are the furniture which are storages. So furniture to sit, furniture to work, and storage. These are the 3 classes. These are the 3 classifications. So where you are taking your students to, you are taking their students to slowly towards object-oriented approach of programming. Looking at the things as the classes of objects, classifying the objects. Passenger, a guest in a hotel, passenger on the railway platform or an airport. So the employees in a school, who are the objects? Students, teachers, management. So this way, what you are doing, you are teaching them object-oriented analysis and design. So these are certain approaches which you can do in your activity periods, bit by bit. So for your activity period, now I have given you a glimpse of everything that what you are supposed to do in the activity period. Now, how will you structure it for entire activity? Suppose you are going to do 2 activities per month, that is 20 activities in a year. Let's say you have planned that I will do 25 activity periods in a year with the students. And each activity period will have duration of 1 hour. So you have 25 hours. So you create a curriculum of 25 hours for your activity period. Abhi, what we are doing the activities in isolation. No. You create a complete flow of 25 hours of a training curriculum for your students, what you will do for logic, and that is all for logic development. And it has to be a proper flow. What will be the levels? What will be the sessions? what topics would be there, how we will start from the very basic and slowly we move on to the system analysis and design in the 20th session. So this way, you create a complete curriculum of those 25 hours throughout the year. And you stick to that religiously, make amendments wherever required, because if you're doing it for the first time, it will need correction also. Certain things might work, certain might not. So you have to change the plan also. But after practicing this for the one session, next year you completely know what to do. And second year onwards, you will be more confident and you will be able to help more students. Many would join in. So this way, for an activity period, you create a 25 hours curriculum only for logic development, not for any programming language. What do you say? Isn't it the right kind of approach to bring the children towards logic development? Because if that logic is clear, 80% of the task is done. And you will see gradually the result and performance of the student is improving in the coding also. Because whatever mind change you will do in the activity, that same mind will go in the classroom. And now that same mind will work on the problems in the classroom. So slowly, whatever they grasp in the activity period, they will apply in the classroom. And you will see the change. So this is the approach. So first thing is, when you go back from this session, you start thinking about a kind of logical approach as curriculum of 25 hours for your students. If you cannot do that, if you do not have that time, I will create one and share it with you. What do you say? Would you like to have that 25 hours or 24 hours logic development curriculum for your students, where you will use only pen, pencil, certain tools, certain interesting software, but not programming language? Maybe you will bring in some programs to show the actual things, but not majorly the programming language, only the tools to develop logic. So that I will share with you. I'll create a curriculum for you all. Give me a week's time. Through our representative, that curriculum will reach you. You are already in touch with the EduSoft representatives, so need not to worry about. I'll create a 25 hours curriculum for you and we will give it to you. Use that curriculum to teach your children logic development. So this is my advice to you for what you do in the activity period that you cannot do in the regular classroom. In regular classroom, of course, you can change the approach of your teaching. So if you are, if in a 40 minutes period, if you are going to teach them about if else, so in programming, always start your teaching with a sample program, with a small sample program. A small sample program and work backwards, intercept the program and explain them what is happening in the program. If you want to teach your children to debug the program, first of all, you show a completely working program, which is working perfectly, which is taking input, giving some output, explain the flow of the program. Of course, now you ask the students to do certain mistakes. You create some errors in the program knowingly. Remove a semicolon, remove a colon, remove a bracket, remove a double quote, or do not import a library in Python. Any kind of 3-4 errors. You start with one error. You remove one double quote and you ask the students to run the program. It will show the error. Explain that error to the students. What is happening in the lab is program is not running. Teacher comes, teacher removes the error. Program starts running. Student is happy. Oh, it is working. Thank you, ma'am. Thank you, sir. But they never went into intercepting what was wrong with the program. What happened? So you do the reverse. You show them a working program and then you play with it. You remove a double quote and you show them the consequences. That look, one double quote was removed and this is what has happened. And this is what the error message means. So they will know, okay, if this kind of error will come, I will look for whether I have closed the double quote or not. You remove a colon, you remove a tab. In Python, there is, we put a tab, indentation. You remove an indentation in Python program and let the students observe, discuss the error. Do not correct the error and move on. Let the error be on the screen and discuss the error. That's the best way to develop logic. One of another approach. And there you will teach them the syntax also and the flow of the program also. And students will be in a natural form of learning where the same program was working fine a short while ago. 10 मिनट पहले ये प्रोग्राम बिल्कुल सही काम कर रहा था और अभी टीचर ने थोड़ा सा डबल कोट हटाया. She removed one semicolon, she removed one bracket, and she removed one indentation, and program went haywire. So they will learn that if this thing happens, what will be the consequences? If this thing happens, what will be the consequences? If instead of a positive value, if I'm giving a negative value in the program, how the program flow is affected. A loop which was running 10 times, if I'm entering a number, now the loop is not running at all. Why? Why the loop is not running at all? Earlier it was running 10 times. What could be the reason? So you do the root cause analysis. We call it RCA. RCA approach. You do something wrong with the program. Program is not working now. And now you rectify the program. You lead the students by asking questions कि कहाँ पर गलती हो गई. अच्छा यहाँ तक सही चल रहा था. There are 10 lines. Till line 4 it was working fine. So leave line 4 lines. Now from line 5 onwards, let us see carefully what is wrong. Oh, this double quote is not there. So you take them to a question asked approach and you do the root cause analysis. That is called root cause. What actually was wrong with the program? So break the code. Yeah, like Deepti Gaur ma'am has just said that she had been doing this practice and she calls it break the code. Yes, that's the approach. So that's the best way to bring the students' curiosity, their attention in the classroom, and shortcut to teach them syntax of the language actually. So that's a good way to, when you are teaching the syntax in a particular language, Python hai, Java hai, that approach you can do. And while you are developing logic, do not go with the errors, go with the ideal situations. When they are developing logic, do not divert them with the errors or debugging. In logic development, everything is ideal. Our solution is ideal, no exceptions. Exceptions will come when we design the actual solution. So this way, you can split logic development through an activity, weekly activity, and syntax and rest of the concepts as usual traditionally in the classroom. But what will happen with that activity? Slowly, your classroom will improve. Your situation in the classroom will ease down. That is what I'm expecting. So, friends, this was my approach about bringing children towards the coding and logic development. That is my approach, which I needed to discuss. The outcome of this discussion is that there has to be a 25 hours curriculum, which I will give you, and that will help you a lot. Around that curriculum, you can do your innovations and tweaking. That's up to you. But I'll give you a common framework to work upon. So this is what I had to share with you all. I hope whatever I have discussed with you will be of some little use here and there. I don't know. You know better because you are teaching the classrooms. So if anything comes to your mind, if any idea comes to your mind here, you can share with all of us. Or anything you want me to add to what I have spoken. Or anything, any discussion you want me to do on any topic regarding this. So please feel free to speak your mind. We still have little time left, so we can do that. Maybe you are facing some other challenge which we can discuss here. Or you might want to know how to deal with the small kids regarding programming, or how to get the younger kids pay attention to you in the classroom when you're teaching the programming. So we can do some discussion here. Or any challenge you are facing anywhere in this. So Prabhat sir has suggested one tool, that is Make Code Arcade software. That's a very nice tool. MakeCode is an online block coding tool by Microsoft, where you can create your own code like Scratch. You can create games, you can create interactive programs, and you can even create coding related to robotics, related to electronics. So MakeCode is a very good software. What we are introducing in our books are RoboMind is there. The schools which are using our books, they know about RoboMind. There is for small kids, we have Kodu Game Lab, and Scratch is always there. And then we have this Kidlo Game Lab. We are on the lookout of more such programs which we can introduce in future. So friends, you can come up with any question that comes to your mind. Maybe you find the solution here. If you're asking one question, it is helping many. Well, meanwhile, when you're thinking about the question, I'm sharing the feedback form link in the chat. You please copy paste it, and I will share it with the EduSoft representatives also. So it will reach you anyway. I have just put it in the chat. So tomorrow, later on, you can, whenever you're free, you can fill this feedback form so that we will be able to create your e-certificates, and those e-certificates will be mailed to you. So you can save this link. It's there in the chat. I have just posted it. So I think if there is no question as such coming up, you can speak your mind. If there is nothing to discuss, then I would like to take your leave, because whatever I had to discuss with you, how to teach lower level classes, how to teach artificial intelligence to lower level classes. That's a very, very hot question. Now, one challenge is artificial intelligence, and then the other challenge is small kids, 3, 4, 5, class 3, 4, 5. Now, when you are moving into a classroom which is having children 3, 4, 5, especially 3 and 4, 5 to abhi is still little grown up, but 3, 4 is a real challenge. The thing is, the children of that age always need experience of something. You cannot talk stories to them. You cannot talk to them. The moment you start talking to them, they will listen to you attentively for a few seconds, maybe a few minutes if you're lucky enough. And after that, they will be distracted. They will find their own distraction. If they're not distracted, they will find it. They will start fighting with the fellow student. They will pick up somebody's pencil. They will start talking. They will start making noise or singing a song. You cannot do it. You cannot do anything. So small kids need a kind of, they want to do the things. They want to be practically engaged into the thing. That's why game-based activities work in small classrooms. But what to do with computers? So my first suggestion is, you take them to the lab. Do not make them sit in the classroom. As much as possible, you conduct the classes sessions in the class, in lab. Now we come to the topic where we have to tell them about artificial intelligence. So first of all, you tell them that, children, think of the computer which is kept in front of you. Think of if it is able to learn like you. You ask them, what have you learned so far? They will tell you A, B, C, D, math, science, English, Hindi, whatever. So you tell them, similarly, if the computer starts learning, and computer is very fast than human beings, so it will learn and will become a genius more than you. So small kids, computer will beat you. Computer will, defeat you if it starts learning like you. So is it possible to learn for a computer? It's a machine. Is it possible for a machine to learn? They will say, no, sir, it's not possible. Some might say yes, doesn't matter. So you tell them, today we are having intelligent computers which are learning, which understand, which identify us. You pick out your mobile phone, show them the face lock, and you tell them, in your dad's phone also the face lock is there, finger lock is there. So my computer understands my thumb, knows my face. and it is allowing only me. So my computer recognizes me just like you recognize me, that I am your teacher. My mobile phone recognizes me by my face, and it will open up only for me. So this way you can step down towards artificial intelligence. Now we talk about what tools are available for artificial intelligence. Now I tell you, one of the tool you can make note, dancing with AI. I am putting it in the chat. I tell you, in AI, all the tools are online available. There is no software as such for that. So you have to have the internet access, and you have to use internet to teach the AI approach. So I'm typing it here. Dancing with AI. Now, this is a platform, you might have heard about it. This is a platform where block coding is there, just like Scratch. When you go there, it will look like a Scratch. But it has many interesting things like you can create a code where it identifies your fingers, index finger, thumb, etc. I will share some very interesting programs with you, which you can use them in the classroom to teach AI to the children. Working programs. It identifies the thumb, and it identifies the facial features, the nose, the eye. There are programs which can count the heads in the video. There are programs there in Dancing with AI where you speak up and it gets converted into text, speech to text. Text to speech is also there. You type in something and it will speak it out. So TTS, text to speech, STT, speech to text, and visual, computer vision. You can tell them about computer vision, like how the computer is identifying the finger and thumb. So this kind of experience you can give them live. They can create their own small code and run it, and they will see when the webcam is switched on, and when their face comes, the sprite goes, the scratch sprite goes and sits on the nose, or the sprite goes towards the eye. You show them the index finger and it goes towards the index finger. Or there is an arrow, there is a sprite which is a car, and with the help of finger, which is visible through the webcam, when you move the finger, the car will move as your finger moves. So those kind of visual programs can be created on Dancing with AI. There is also another platform I'm telling you, machine learning for kids.uk. Machine learning for kids.uk is also such platform where graphical coding can be done. So I will share with you these certain links here. Just give me a moment. Let me see if those links are available with me. So you can use them to engage the children practically into coding. So I have told you Dancing with AI, machine learning for kids.uk. Let me see if I have that list. I'll be able to share it right now with you. Just give me a moment. I'll just give you certain URLs which will be useful for you. Yeah. In chat, I'm sharing certain links. You can please copy them and keep them safe. If you want to teach, give AI experience to the students. These all are online tools which you can use to engage the kids into artificial intelligence. From EduSoft, the book which is made for artificial intelligence in telecode for class 6, 7, 8, for class 6, 7, 8 can also be used. There are many activities in it which even small children can do. I'll give you some more tools about it. There is another link I'm giving you, playground.raise.mit.edu. So these are the links which you can use to engage the children throughout the year to teach artificial intelligence. So, sir, I think this much will help you in starting with AI. You can try out these links and they will be really useful for you. In near future, we will be using these links to create a coding curriculum for the schools. Well, any other questions, any other idea you want to share, or your experience or any challenge? You please let us know. Or you can unmute yourself and you can ask your question also. If you're comfortable with chat, that's fine. You can put it in chat. So friends, we come to the end of our session, and it has been a long time I have come online from EduSoft. It's a long time. This is now the series of webinar has started, and we will now try to put up regular webinars. Keep coming, keep learning many things. You can also tell us in the feedback form. You can also tell us on what topics you would like the webinars on. So in future, we can plan the webinars accordingly. So this was some topic which was required by many people. So we did it. And if a feedback comes from you that you want a webinar on this particular thing, then we can arrange a webinar on that. So that won't be a problem. So it was all nice talking to you all here in this session. And thank you for dedicating your Saturday evening with me, 1.5 hours. And it's really commendable. And I am again thankful that you have listened to me with patience. And I strongly hope that you are taking away, as usual that happens in our webinars, you are taking away something useful from us. If that has happened, then the purpose of the webinar is solved. I am happy then. If it has solved a little problem of yours, that's my achievement. That's EduSoft's achievement. So friends, with these words, I thank you again, all of you, for coming in here, making it a great gathering, and have a nice weekend. I'll see you again soon in another webinar. Thank you, all of you. Have a good night.
Thank you, sir.